I'm going to show why vitamin C is encouraged to be consumed alongside dietary iron to help its absorption. So non-heme iron or ferric iron or Fe3+, is soluble at low pH or acidic pH, such as that in the stomach of a 1.5 to 3.5. In the stomach, it remains soluble, it's mixing with all of the fluids. Now, when ferric iron is in a more neutral pH, such as when it goes into the duodenum, which has a pH of 6, it starts to form precipitates, meaning it no longer mixes with the fluids, it starts to aggregate towards the bottom, it's clumping together, and it doesn't have the chance to be absorbed, so it will likely be excreted. The first function of vitamin C with iron is expressed here. So vitamin C acts as a soluble iron chelator, meaning within the stomach, vitamin C will bind to ferric iron. So if you have vitamin C in the stomach, it will form this complex with ferric iron. It binds together and it will travel through the stomach and into the duodenum, and even in the presence of this more neutral pH of 6, it stays bound together and it will remain soluble in these fluids until it's absorbed. Now let's look at how vitamin C assists with absorption at the brush border membrane of the duodenal enterocyte. So we begin here. You've got ferric iron or non-heme iron. To be absorbed, ferric iron has to be first reduced to ferrous iron, Fe2+. So what that means is ferric iron needs to be reduced. It needs to receive an electron because oil rig. Reduction is gain. How this happens, there is an enzyme called duodenal cytochrome B, commonly known as ferric reductase. This enzyme transfers an electron from vitamin C through its enzyme onto ferric iron to form ferrous iron. Now that ferric iron is now ferrous iron, it can be transported by DMT1 into the enterocyte to continue its pathway of absorption. And that's how vitamin C assists with dietary iron absorption.